Okay, this is Mr. Weideman, and I want to talk to you about the equilibrant vector. In our homework problem worksheet, you saw several problems, and you see this word equilibrant. What does it mean? Well, equilibrant is something that we borrow from chemistry. Spin off on the word equilibrium. Now, when we use equilibrium in chemistry, specifically it means no change. And when we talk about chemistry and a chemical reaction, we specifically mean the reaction is complete. There are no more changes occurring in the matter. In physics, it also means no change, but specifically it means there's no change in motion if forces are in equilibrium. So what do I mean by forces in equilibrium? And in physics, if the vector sum of all the forces add to zero, because the forces cancel each other out, then the motion of an object will not change. This does not mean the absence of forces. This just means all the forces present cancel each other out. Imagine somebody pulling on an object 10 newtons to the right and another person pulling on an object 10 newtons to the left. Well, there's obviously forces present, but they cancel each other out. And since the sum of the forces cancel each other out, it's said to be in equilibrium. There'll be no change in motion of the object. We'll get in this to much more depth when we talk about forces and Newton's 3 laws of motion. Okay, let's look at this first problem where equilibrant appears in your homework. And you say, well, that's not exactly what the problem says. It says, what single force would replace the two forces? Well, I've just rewrote that and says, what is the resultant of these two forces? I can take multiple forces, add them together as vectors, and replace all those multiple forces with one single force vector. And not just forces, I can do that with all my vector quantities. All right, and then it says in your homework what single force, called the equilibrant, would balance the two forces. And I reworded that to say I've got two forces acting on the object, and I want to add a third force. So the 80 Newton force and the 100 Newton force and this third force that we're going to compute, when added all together, will equal 0. The third force that will be applied cancel out the effect of the other two. Okay, now let's talk a little bit about canceling forces out. Okay, so I've got an object and I've got this 80 Newton force acting on it. How am I going to cancel that out? If you said, I'm going to apply 80 newtons in the exact opposite direction, you're correct. In this case, I've got my original vector A. Vector B is in equal magnitude but opposite direction. So if I add vector A to vector B will cancel out vector A. So we will call, in this particular situation, vector B is the equilibrant. But that's not our problem. Our problem is we have more than one force to cancel out. This complicates things. See how we handle it. All right, in our problem, we have two forces. And we're going to call these forces A, and we're going to call these forces B. Now what I've done is I've used the component method, check my calculations. When I add these two vectors, A and B, together, I get a resultant of 156 at 86 degrees. Note my notation. A plus B is equal to, I call it R, which is the sum of A and B, or the resultant of A and B. All right, so what I can do now is I can take my two forces that we had before and I can get rid of them. And I can replace them with one single resultant force, which is what I've done here. Now I'm back to the original scenario. How do I cancel this out? Same way. There's my resultant force. which I got by adding vectors A and B together. And I'm going to cancel that out with this force that I call C. C is equal in magnitude, but opposite direction. So if I add C to the result of A and B, then I'm going to have 0. So here's our original situation. Here's our two forces that were given a problem. I labeled them A and B. And then if I add force C, then it'll equal 0. So force C will wipe out the effects of forces A plus B. Therefore, I call force C the equilibrant. Right? And this works with multiple forces. This is two forces. I could literally have 10 forces acting on an object, which means that I will probably need to add an 11th force to cancel out the effect of the first 10. How would I do that problem? I would take the 10 forces, add them up together with the component method, and find the resultant. The equilibrant will then be equal in magnitude, but opposite in direction of the resultant of those first 10 forces. And that's the equilibrant. And I hope this helps you work your problems. Thank you.